Okay, so we're going to use logs to isolate an exponent here. So we've been given some base to some power, or the base of 2 to some power is equal to 256. What's the base? Well, one way you can kind of figure it out is kind of trialing and erroring your way through this, right? We can go 2 to the 4 and run that through a calculator. Does that get it? No. We can then go to 2 to the 5, 2 to the 6, and eventually we're going to stumble upon the answer, but this is all trial and error. So we're looking for an algebraic way to solve this. So there's a bunch of rules with something called logs. I'm going to just show you the shortcut here. What you'll want to do is just like when you're adding or subtracting, if you were to add 1 to this side, you have to add 1 to this side. What we're going to do is we're going to take the log base 10 of both sides. So what does that look like? That looks like this. We're going to say log. Now, technically there's a 10 written down here, but if we don't write anything, which I'm going to do on the other side, it's assumed that the base is 10. Kind of like when I write the number 2, it's assumed the exponent is 1, so we don't really write it in. If I don't write anything down here, it's assumed that the base of the log is 10. Okay, so we take log 2 to the power of n. So I've taken log base 10 of both sides. This one's going to disappear, but just to show you that these are equivalent. When you do that, what it allows you to do, because of the way a log is technically set up, is you can now take this exponent and kind of multiply it in front. Think of it like you're pulling it to the front now. So without doing anything else, we're going to say log of 256 is equal to, this n is now multiplied by your log base 2. So again, this has to do with how logs are equivalent to exponents, but when you take the logs of both sides, it allows you to bring the exponent and make it a number that is then multiplied by this. Okay? Your calculator will calculate log base 10. So if the goal here is to isolate for n, that's been our goal the whole time, to solve for n, think of it like this now. We now have n, put in brackets, times log 2 is equal to log of 256. Well, to isolate n, because this is multiplication, I divide both sides by log 2, right? So I'd say log base 10 of 2 and divided by log base 10 of 2. On this side, these guys create a 1, they eliminate each other. And on this side, we just calculate. Now, we won't calculate in our head, probably not something you and I can do. I'm sure there's somebody somewhere who can. But our calculators can definitely do this. So log base 10 of 256 divided by log base 2 is equal to n. So we'll bring out a calculator. We can use Desmos as a calculator here. I'm going to say log of 256 divided by log of 2, and it gives us the value of 8. Okay. So in this case, n is equal to 8, and we can test this theory. Let's say what's 2 to the power of 8 is equal to what? It should be equal to 256. We'll use a different calculator just to verify. 2 to the power of 8, 256. Great. So without going into too much theory about the logs, if you're ever set up with this relationship in math, some number is equal to a base and the exponent is the unknown, we just take the log base 10 of both sides. The exponent is kind of like a recap, drops down to the front and is now multiplied by that. And then we just divide to isolate for that exponent. Okay? And your calculator can do this. You don't have to quite know what that means there. Okay?